Hi, I'm Joe Wilder. In today's video, my partner Casper and I are going to show you how to use the laser cutter we have here on campus. For this video, we assume you already have a basic knowledge of SOLIDWORKS, as well as a part that you want to fabricate. We'll show you how to take that model and turn it into a finished product. Before we do that though, Casper is going to talk a little bit about the practical considerations of using the laser cutter, like what kinds of materials you might want to use, or when to consider another fabrication process, such as 3D printing.
On campus, a number of machine tools including the laser cutter, 3D printers, mills, and lathes are available for you to use. For this course, you may want to consider using one of the first two options. The laser cutter offers higher accuracy cutting with quality finishes. Although the same can be achieved using a 3D printer, the laser cutter typically runs much faster and has a larger workpiece area. Both wood and acrylic are suitable materials for constructing your robot. Wood typically runs much cheaper than acrylic. It's worth noting that other materials are also able to be cut on the laser cutter, but you must consult a lab monitor beforehand. If your design has small, complex 3D structures that are small in cross-sectional area and in volume, you may find a 3D printer more suitable. Additionally, some materials used in 3D printing have useful properties, such as flexibility. For more information about 3D printing, consult the Robotics Wiki. Today, we'll be cutting the parts for a simple robot. They were designed previously using 3D modeling software, and we'll go through the steps of converting them into a usable format and sending them to the machine. Before you even enter the manufacturing lab, you have to register your project and book time on the laser cutter. You must have the basic user qualification in order to do this, so you must register with the shop if you haven't done so already for this year. To register, take a short quiz on the manufacturing lab policies. Once you've done this, go to the registration page of the website and fill out the necessary information. If and when your project is approved, you should be able to access the machine tool schedule. From here, select a block of time that's free and add a new event. Fill in the window that pops up and hit OK. You should receive email confirmation once your request is either approved or rejected. Ours has been approved. Now, we can start to create parts for laser cutting. First, we need to model the parts we need to cut for our robot. For this, we're using SOLIDWORKS. You should also be able to accomplish this in other modeling software, such as Inventor or AutoCAD. Here, we'll show you how to export parts individually. Advanced users may be able to do multiple parts together in an assembly. We've gone ahead and designed a simple robot to demonstrate this process. I'll open up a model of the top plate. It's used to hold together 4 plates, 2 for each set of wheels. The WPI logo will be engraved on the top. Now, we need to turn this SOLIDWORKS part into a drawing, or DWG file. This is an Autodesk proprietary file format used for storing 2- and 3-dimensional design data. Before you export this file, the first thing you want to do is adjust the view so that your model is in the correct orientation for laser cutting. The DWG file is like a snapshot of the SOLIDWORKS file in its current position, and you have to remember that the laser cutter essentially needs a 2-dimensional drawing that it can cut. So think of the drawing file as showing what you want your finished product to look like when it is viewed from the top down. So we're going to orient the part like this, and now we're ready for export. To do this, go to File, Save As, and then choose DWG in the File Type drop-down menu. SOLIDWORKS will automatically open up a preview of the DWG file, so you can ensure that your part looks exactly how it's supposed to.
The next steps are to prep the drawing and then send it to the laser cutter. The first thing you'll want to do is open up the drawing file that you made in AutoCAD. And we're cutting multiple parts for this project, so let's go ahead and open all the files that we'll be needing to cut. When it asks you if you're sure you want to open the file, just press Continue Opening. There. Now that we have the file in front of us, there's a couple of things we need to change in order to prepare this drawing to be cut. Let's start by getting rid of all the lines in our drawing that we don't want cut, like this bit of SOLIDWORKS text here. Now we select the whole drawing and change the line width to be either 0 or 0.05 millimeters. This ensures that the laser cutter correctly interprets the lines in your drawing. We also want to change the line color to be red, which is important because it tells the laser cutter to cut all the way through. If we want something scored instead of cut all the way through, you make those lines blue. To engrave a feature, make the lines black. Follow this process for all the parts you want cut. Now, we're going to put all the drawings in one document. This allows us to arrange the parts in such a way that mitigates the amount of material we waste. All of this work can be done on any computer that has AutoCAD installed, so we recommend you do this ahead of the time you booked on the laser cutter. This way, you can begin cutting as soon as you get to Washburn. The next steps, however, need to be done on the workstation next to the laser cutter in the shop, which is where I'm working as I do this. Alright, our drawing looks good, so now it's time to send it to the laser cutter. Go to File, Print, and you should get this pop-up menu. We want to select the VLS 4.60, that's the laser cutter. When prompted, select the Use Default Paper Size option in the dialog. Now set the What to Plot setting to Extents, uncheck Fit to Paper and set the scale to 1:1, and then check Center the Plot. This all ensures that your drawing will be properly sized and formatted when it gets to the laser cutting software. Double check the little preview window in the print dialog doesn't have any red areas. This indicates that your drawing won't fit on the laser cutter. If everything looks good, you can just hit OK. Now let's take a second to get everything set up in the work area. Assuming you're already set up on the workstation next to the laser cutter, pressing the power button should now turn the machine on. Now go into the welding shop next to the laser cutter area, provided no one is using it, and set the ventilation switch to either auto or hand. You should begin to hear air flowing. This ensures that smoke from the laser cutting process is sucked out of the cavity. Once this is done, you can load in your material, keeping in mind that the maximum size for this laser cutter is 18 by 24 inches. If your stock is larger than this size, you can also ask a lab monitor to help you cut it down. Or, if you're an advanced user and have a second advanced user to watch, you can do it yourself. Now we're ready to open the laser cutter software. You can do that by clicking on the little red icon on the desktop. Let's take a minute to familiarize ourselves with the GUI we now have in front of us. The large white space represents the cutting area. You should be able to place your drawing anywhere on this area. You can use the button shown here to change the location. This button can be used to zoom in on your drawing, if need be. If you lift the lid on the laser cutter, a red light should appear below the laser. The focus button can be used to move the position of the laser around in the cutting area. This is useful for determining where on your stock material the laser will cut. You can also duplicate your drawing using the duplicate button, which is useful when you have to make multiples of a part. There's no need for duplicates here though, as we've already taken care of that in AutoCAD. Once you've used these tools to properly place your drawing in the build area, you have to let the laser cutter know what thickness and type of material you're using. This can be accomplished by clicking on the Settings button, which brings up the Materials database. Scroll through to find the material you're using, and then set the thickness. For us, the material is birch and the thickness is 0.25 inches. Now you're ready to begin cutting. Once the lid is closed, press the play button in the laser cutter software and let the laser cutter work its magic. Make sure to stay nearby and watch the laser cutter though, just in case. The laser cutter starts with marking, and once this is done, it uses greater intensity to make the cuts. Also notice that it makes inside cuts before it makes outside ones. Once the laser cutter is done, you can remove your parts, making sure to clean up all additional debris as well.
Here we have our finished product. These plates are designed so that they can be assembled with screws and nuts, but glue or acrylic solvent can also be used. So now that you've seen what the laser cutter is capable of and how it works, you'll hopefully be able to bring some of your own ideas into fruition.